Okay, so I guess PS12 is still available with the late day. So I'll ask if there are any questions or problems I could help with. So if you're still working on it, there are a handful of things that seem to be pretty common questions, so be sure to check for an answer on PLs before you post again. Okay, so we have an exam coming up, and it's 2 days from now. So the final is Thursday from 1 to 3 in either this room or the other room. It's in 102 if your last name starts with A through F. In here for G through Z, it's just the same as the midterm was, the rooms. And it'll cover the entire semester, so it's comprehensive. You can bring 2 sheets of notes, front and back, printed or handwritten, whatever. And the review is going to be tomorrow from 1 to 2:30 in here with Jakob. He will go over the sample exam that I posted. I'm going to do something different today, so he'll go over the sample exam with you. The TAs and I finished regrading PS, I've dealt with all the regrades through PS6 as of about half an hour ago. And my goal is to have 7, 8, and 9 done today. There's just a few that need to be done there. And then I think the requests for regrades on PS10 were due pretty recently, so we haven't started looking at those yet. The grades for PS11 and 12 should be out pretty soon. So if you have any grading issues, like I've already heard from one pair that had sent a message to a TA about a problem and never heard back. So if there are any issues like that are still pending where you haven't heard back from somebody, let me know about it. So resend the message to me, and I'll make sure it gets dealt with, because I'd like to deal with all the grades this week if we can. So any questions about any of this, what I just said? Yeah?
So in CS 2100, there's the final exam also on Thursday, 30 minutes before this final. Will we not be able to take the exam if we show up a couple minutes late? The test is on the set of cameras.
Oh, yes. Yeah. We'll let you in.
Okay.
Okay. Anything else? All right, so in December, when I was giving the 1410 final exam over in Gardner Commons, the building caught on fire. And so I'd never thought to come up with a plan for what to do when the building catches on fire. But I have one now. But I won't bother you with it unless this building catches on fire. All right, before we do a review, there's one more topic I want to talk about. And that is, this is a booklet. Let me find the title of it. The ACM Code of Ethics and Professional Conduct. So I traditionally talk about this at the end of the class, and the previous Code of Ethics was about 25 or 30 years old, and these were just adopted in the last year. So first of all, what's the ACM? Anyone know what the ACM is? What's the ACM?
The Association of Computing Machinery.
Okay, so it stands for Association of Computing Machinery. It's the sort of the most prominent professional organization for computer science. The name's kind of old-fashioned, computing machinery, but that's what the ACM is. And they've adopted a code of ethics. And as you're students now and you become computing professionals, it's good to keep in mind that there are some ethical principles that can guide your behavior on jobs or whatever. So I want to talk briefly about them. And like I said, these have changed in 25 years because computing has changed quite a bit. But the number one, these are the sort of the general principles. We'll just look at the general principles. There are more specific ones for depending on what your role is. But the number one now and 25 years ago was pretty much the same. A computer professional should contribute to society and to human well-being, acknowledging that all people are stakeholders in computing. So the old guiding principle was something like your number one responsibility is to society. So what does that mean? What does it mean to acknowledge that all people are stakeholders in computing? What does that say to you? Yeah.
Software runs a lot of our systems, so there's ethical implications. Because if you write bad software, you can harm somebody.
Okay, so bad software can harm people. Where have we seen that lately? What kind of harms have you seen from bad software? Yeah. Yeah, the two Boeing jets that have crashed recently appears to be a software problem. The planes, it was the old 737 design, but they redesigned it to put different engines on it, which changed the balance point, which made them kind of unstable. And so they're using software to compensate, and the software overcompensates sometimes and crashes the plane. What else? What other harms can computing cause?
Well, there was a bug in Microsoft's SMB a while back that allowed for arbitrary code execution.
Okay, so yeah.
I feel like it's about every other week I see something about Facebook has some bug and people lose passwords or information.
Okay, so security and privacy problems. Yeah. Yeah.
It just got released that Russia was running simple SQL injection attacks on our voting system, and that's what was getting them into voting databases.
Okay, so not on the voting database, does that affect the votes on the election day and count?
It affects society, yeah. It allowed them to get in, and we don't really know what they did with it.
Okay, that's enough. Yeah.
It's kind of like a touchy issue, but autonomous vehicles could be very harmful.
Okay. You know, there's some. You know, it's easy to see benefits from autonomous vehicles. It's also easy to see dangers. You know, computers are used to control lots of medical devices. And they're classic examples of software that killed people, basically by giving them far over the allowed dosage of radiation. So it's not hard to come up with problems that computing causes in society. And so what this ethical guideline is saying is that you can't be very narrowly focused on what your employer wants. Your duty is not just to your employer. If you're creating systems that are going to be used by society at large, you have a professional responsibility that your systems aren't harming society. Okay, and this is related. Avoid harm. Avoid negative consequences. So you need to think about what you're doing and what the downsides can be. Okay, honest and trustworthy. Those are trustworthy. Scott is trustworthy. The first point of the Boy Scout law is trustworthy. So this is, I guess that's sort of goes without saying what that means. Be fair and take action not to discriminate. So how can computing systems discriminate against people on the basis of race or ethnicity or gender or whatever? Yeah.
Facebook's ad agency, they are able to pull very specific groups, and they've gotten in trouble for selling ads to too specific of a group.
Okay. Yeah.
I think it was Microsoft's hiring board was searching resumes for certain keywords, and it turned out that men had those keywords more than women. So.
Okay. So the supposedly completely objective computer program was sort of adopting the biases of its creators. So we have a professor here, Professor Subramanian, who he's an algorithms researcher, but he's also interested in he's a board member of the local ACLU chapter, and he's interested in sort of the ethical implications of computing. And he published a paper that showed ways in which machine learning can pick up the biases of the training set that it trains on. So if, the way machine learning works is you take a whole bunch of data that shows decisions, say, that people made. Let's say if you wanted to have a machine learning system learn how to approve people for loans. Well, so you look at historical records of loan applications and whether the loan officer decided to approve it or not. If the loan officer was biased, the loan officer was racist, then the loan officer was making racist decisions. The machine learning system will just learn how to make racist decisions from that. And he ended up on Science Friday talking about the results of that research. So it's a serious thing. What's this about? Respect the work required to produce new ideas, inventions, creative works, and computing artifacts. Yeah.
Cheating extends beyond the classroom.
And he said cheating extends beyond the classroom, right? This has to do with intellectual property that we talked about last week. But there's something down here. There's a point I wanted to point out. It says computing professionals should not be unduly oppose reasonable uses of their intellectual works. So, share. Respect privacy. We've already mentioned some of the ways in which computer systems can violate privacy. I just saw I was reading something online. A federal district judge had ruled that the practice of marking tires on cars that park to see if they park for too long is unconstitutional. So, the parking officers will come and mark chalk on a tire and come back 2 hours later, and if the chalk is still on there, that means the car hasn't been driven. It's been sitting there for 2 hours, and that's too long, and they get a ticket. And so that was this judge ruled that it was a violation of the that you need a search warrant it was an illegal search to mark the car. And then they went on to say that it would be okay if what they did was photograph the cars and photograph their license plates and record the license plates and so that when they came back, that's how they enforce parking at the U, is by scanning the license plates. But that, since it didn't involve actually touching the car, it wouldn't be a search. And I was thinking that, if I had my choice between the police marking my tire with chalk and the police recording everywhere I park, which is the greater potential harm? It's the privacy concern is a much bigger concern to me than whether they're going to mark my tire with chalk or not. Okay, and then honor confidentiality. So if you get, if you're privy to confidential information as part of your work, you need to keep it confidential. All right, so it goes on to talk about, I'm not going to dwell on this, but it talks about professional responsibilities and responsibilities when you're a boss and so on. So I encourage you to take a look at this. It ends with some case studies that show how to apply these principles in action. And if you don't remember anything else, just remember that your first duty is to society. There it is. The ACM, for whatever reason, chose to make that the very first point in the ethical principles. Think about the impact that what you're doing. Think about the negative impacts that what you're doing can have on society and try to mitigate them. Okay? All right. So I want to remind you what you learned this year and this semester. And the idea is to, as I remind you, you can ask questions so that you can be prepared for the final. So let's take a high-level overview of what we've done. You've learned C#. You've learned a number of programming techniques you might not have seen before. You've seen some software architectures you may not have used before. You've used a whole lot of different software development tools. Hopefully you've honed your personal software practice. And there's various other topics, such as intellectual property and the ethics that we just talked about. So before we go any further, what would you add to this list? What have you learned this semester? What? Yeah.
Well, I think the fact that we've had to do the full second half of the semester with a partner, we've learned different levels of teamwork.
Okay. So you learn maybe how to work with other people, or maybe how not to work with other people. I mean, it goes both ways. So what else have you learned that may not be on this list? Yeah.
Get merging.
Okay. So Git merging. So yeah, you've had lots of practice with Git. Yeah.
Kind of the whole development process, like with the spreadsheet, for example, like from like starting with something small and working on it bigger until you get a final
Okay.
project.
So living with the spreadsheet project for 5 weeks was probably different than you'd done before, really 6 weeks. And then Boggle again here at the back end. Yeah?
Rapidly fixing issues with previous week's assignments.
Okay. Rapidly fixing issues. So I saw that there was a pointed question when Eric Olson was in here about, he was talking about how the bosses were very forgiving if you didn't get your work done on time, and it was okay to put it off to the next sprint, the next 2 weeks, and that's not how school is. And I understand that. It's just we have a limited amount of time. We got to finish things up. So I wish it was possible to be more flexible. Yeah.
I feel like I improved my debugging techniques.
Okay. Through just diligent debugging.
Yeah.
And honed your debugging technique. Yeah.
I learned how to navigate documentation a lot better. So
Okay.
A lot of times when you have a problem, somebody else is probably encountering it. There's a pretty specific way to handle the problem.
Yeah. So what kind of documentation did you find was valuable?
Oh man, so much. I've read so many at this point, I don't even know, man.
Yeah. I mean, so like the .NET, the Microsoft documentation for .NET is pretty extensive and pretty good. Where do you go when you've got some weird issue in Visual Studio where something won't build, or Stack Overflow is where I don't really go to Stack Overflow and search. I just search on Google, but it always seems to point me to Stack Overflow. But when you go to Stack Overflow, you've also got to realize that if that's not always right, you've got to develop the ability to judge what you're reading and see if it makes sense and applies to your situation. Okay, so it's been a pretty broad experience on a lot of topics. So hopefully you take something away that you didn't know about before. So you know that in C# solutions consist of multiple projects, and there are all kinds of projects that we've used. Everything from console applications to installers and web projects and so on. One thing that I realized too late, like 5 years too late, is the surprising number of solutions that are submitted for assignments, say PS6 in particular, that don't build. So people would hand in solutions, and the TAs would go to run the test cases, and they have to build the project first, and it wouldn't build. And they would have to spend time fiddling around to make it build. And the reason it didn't build wasn't because there were syntactic errors in the code. Why do you think, what's the problem that made it so things wouldn't build? Yeah?
Wrong net framework version.
Okay, so there could be an inconsistent .NET framework version, but you'd think that if it built on your computer and you submitted, you pushed it to GitHub, it should build on the TA's computer. Yeah?
Maybe you weren't using like general paths to some files that you...
Occasionally that's a problem. That's more of a runtime problem where you have absolute paths that only exist on your computer. Yeah?
Maybe the wrong project type.
Wrong project type? I mean, that's a possibility, but still that's going to be, it was the same on your computer. Yeah?
References getting lost.
References getting lost, yeah. So that's getting closer to it. So what I discovered is you do a merge, and if you're not careful about how you do the merge, one problem that occurs is that some of your projects are unchecked from being built. And you don't notice it on your computer because they're already built. The object files are already sitting around. So let's say you're working on your spreadsheet program and and you don't realize that when you build it, it's no longer rebuilding the formula project. You don't notice because it's not changing and the object files are already sitting, the DLL is already sitting on your computer. But when you hand it in, it won't build for the TAs until they go and recheck the box that says build formula. So what I realized way too late was that I should tell people before they submit the commit, do a clean build on their computer to make sure that it builds. That would really save the TAs a lot of time, I think. So anyway, it's sort of a long-winded way of you can survive not really knowing what's going on behind the scenes in Visual Studio with .sln files and .csproj files, but at some point that becomes important, and you can, once you sort of have a model of what's going on, you can it gets a lot easier to troubleshoot problems. Just remember that when I use the word assembly, I'm talking about the thing that something builds. So when you build a project, you're building an assembly, often an exe file or a DLL file or possibly a website. And CIL stands for Common Intermediate Language. That's what everything compiles to when it runs on the Common Language Runtime. This is some of the stuff we've learned about C#. So going into the final, you need to be familiar with this stuff. So, we have namespaces. It's the same idea as packages in Java, but kind of more powerful in that it doesn't have to have a one-to-one correspondent with folders like it does in Java. And we looked at classes and structs, so know what they are and what the difference is. Inheritance and interfaces. IEnumerable, which is tied in with IEnumerator. Delegates, anonymous methods, in other words, lambdas. Events, the stuff having to do with multi-threaded programming, multitask programming. We did less with sockets and TCP clients and TCP listeners this semester than in past semesters. That was sort of a deliberate thing on my part. So in the past, there was an additional assignment where you built the string socket. So first you built the string socket, then you used it. And I did away with the building the string socket part. But if you had to build the string socket, you would have worked at a much lower level with sockets instead of string sockets as you're doing in PS12. And that'll be reflected when you look at the sample final. There'll be questions about sockets that are a bit lower level than I'd be asking this year. Learned about using SQL from C#, and you had to do some annotations when you did your web servers. Anything up there you can think of that also belongs up there? Stuff about C# that you learned? Anything in the language that you hadn't used before? I don't always remember everything that needs to go on these slides. Or any questions about any of these topics? The main reason here is to review and to answer questions. Yeah?
Sorry, you said, so since we didn't do that, that would reflect the sample. The questions that you're referring to, are they the ones on the very bottom, like 23, 24, 25 of the sample?
I don't remember. What were they about? Sockets?
Yeah, they were about sockets.
Yeah.
It was just like a fill in the if else for this, and then...
Right. So those are questions. Those questions are about low-level socket programming that you didn't do. So yeah, I wouldn't ask questions like that.
Okay, that was scary.
Yeah. I would just, it wouldn't be so scary if you'd spend a week implementing string sockets. So what I might substitute for those would be questions about string sockets. Yeah.
Window forms and panels.
Okay. So yeah, all the stuff that you learned about. Well, I guess that falls under support for GUI clients. Yeah. Yeah?
I can't remember what it's called, but you use like the out keyword inside of.
Oh, okay, that's true. That's missing. So call by reference.
Call by reference.
Yeah. Call by reference versus call by value. So, there are topics, and then there are topics it's easy to make up questions about. And call by reference is definitely one that's easy to make up questions about. So, yeah, you need to understand the difference. Yeah?
I guess that was PS1 with the pipe and filter, the command line.
Okay. So we'll have some more slides about software architectures, but yeah, writing main methods and using pipe and filter at the operating system level. Okay. Any questions about how any of this stuff works? Okay. We talked very early about iterators, this sort of pattern right here. So that's sort of a neat thing about C# that you don't see in a lot of other languages. The ability to have something that looks like a method but actually is something that incrementally produces an enumeration of things. So this is one that returns, iterates numbers in a Hailstone sequence. And the cool thing about iterators is they can generate infinite sequences. I think we saw an example of that on the midterms. You can have an iterator that generates, just starts spitting out prime numbers. Okay. Any questions about this? Okay. I remember when I introduced the idea of delegates, I told you that it's not a topic that would blow over, that you would need to you'd be using it all through the semester. And indeed, think about the thing you're doing this week, last week, the PS12. Where did delegates come in there? Yeah, the callbacks in the send and receive methods. So you couldn't have made any progress in that assignment without using callbacks. Where else did delegates occur? Just methods as parameters. Yeah?
The formula assignment?
Okay, in the formula assignment, there's a delegate to look up the values of variables. Where else? Yeah? Okay, so to run a task, you have to give a delegate to run. That's true. You think back on when you did the stuff with graphical user interfaces. That's all about events and delegates. So it's not it's a major thing that was used over and over again. So you need to be, and this is another thing that's easy to make up questions about. So you need to be sure that you understand things like lambda expressions, which are often used when we need to pass a delegate, just to cook one up real fast. You need to understand this type notation that gives the fact that this delegate is supposed to take two integers and return a boolean, or the equivalent one for action, which isn't up here. Or understand that you can, this is declaring a delegate type. It's just saying a comp is going to be a delegate that takes in 2 minutes and returns a bool. Sort of the same thing as that says. Just gives a name to that pattern. So I'm sure you're pretty used to it by now. Events, that's an aspect of C# that you probably didn't see in Java. So it's just an asynchronous way of triggering a delegate, triggering a method. And it shows up a lot in GUI interfaces. It also shows up in sockets, but we didn't really look at the low-level sockets. So you need to understand how you declare an event and how you fire an event. So these are examples over here of hooking an event. And to fire it, you just make sure it's not null, and then you just call it as if it's a method in there. Any questions about that? Okay, threads and tasks. So I never talked to you about PS8. I realized too late that, so I made up PS8, and I didn't do it myself, and that's always a mistake. And I even, I had a nagging voice in my head saying that I should do it myself. And the mistake that I made in making that assignment up was I am too willing to treat tasks and threads as the same thing. In reality, threads are low level, tasks are higher level, and you can, threads can be reused. And so you can have a situation where you have a task and it runs, and then you have another task and it runs, and it ends up running on the same low-level thread. The two tasks end up running on the same low-level thread. And it's also the case that a lot of the low-level synchronization primitives, including the ones you were using for PS8, know about threads. They don't know about tasks. So how could that problem cause a problem? Remember with PSA, where you're trying to write test cases against different implementations of read-write locks. Think about what it would mean if two separate tasks could end up running on the same thread, and locks are specific to threads, not to tasks. Yeah.
Well, I mean, wouldn't you run into the issue of like double writing them if they're specific to threads and not tasks?
Okay.
Tasks enter the same thread and modify data.
Right, so it's possible, let's say you have a task which sets a write lock and then doesn't release it, and then the task just ends. So you might think that's no big deal, but what might happen then is the next, say this is part of some test case you're doing, so you create another task to set a write lock on the same thing, and you expect it not to be able to acquire the write lock because it exists on the other task. But that write lock still exists on the thread that this new task is running on. So basically, locks set by some task that's already run on a thread can can interfere with locks on a new task that happens to be running on the same thread. That is one reason of several why a lot of you found that if you ran all the tests at once, all your tests at the same time, they didn't work right. But if you ran them one at a time, it worked okay. It was, I know I haven't done a very good job explaining this, but the interaction between threads and tasks was causing problems there. So I do a very different assignment. So what I did was I just graded very leniently. It actually took days of effort, well, not my effort, computer effort, to run the task, because we ran each test case separately, and it took a long time to do. And then I tried to be very forgiving about the grades. And in the end, only one group complained about their grades. So I think I must have done an okay job. Okay. Anyway. You've had a fair amount of experience with tasks. It's an approach to concurrent programming, and you have to be aware of it in GUIs, because in the GUI, the thing is everything has to happen on the GUI event task, and it's important with the sockets you're using. You can't lose sight of the fact that you are, when you go to read, when you call begin receive, the callback is going to happen on a different thread probably. So your code is inherently multi-threaded. And we talked about different ways of doing synchronization. Okay, what questions could I answer about this? I can yak all day, but in the end, if you want a question answered, you have to either ask it or compel someone else to ask. So. Yeah.
How did these work when there were only like single core CPUs, or if even some of us were running on like a dual core and doing something with the GUIs? Because the GUI is supposed to take one of its own, right? How does the system allocate enough?
So how does or did multi-threading work on single core computers? Okay. Well, the truth is there can be many more threads than there are cores. So it's not just an issue for a single core computer where there's one core and you have multiple threads. You could have 8 cores and you could have dozens of threads. And just the same way that you can have 8 cores and have 100 processes running at the same time. And it's just done with time sharing. So when there are not enough cores to go around for all the threads that need to run, you just let some threads run for a while, and then after a small amount of time from your perception, the thread is interrupted, the state is saved, and another thread gets to run for its turn. And then later on, this thread is restarted. So what do you have to save about a thread so you can start it up later? Yeah?
The instruction pointer register and some stack.
Okay, so he said the instruction pointer register. You have to know which line of code is being executed currently, and you need to save the state of the stack. So you got to save the stack away, and it's presumably the heap is being shared, so it doesn't really have to be saved away. So you save the stuff specific to the thread, and then later on, you just pick up where you left off. Any other questions? Okay, we talked about socket programming. You're doing sort of low-level string-oriented communications over a socket. That's what I call this. That's the string socket. The real sockets are even lower level and do byte-oriented communications. So the one big advantage a string socket gives you, with a regular socket, you say, give me some bytes. It's not like you can't count on getting any particular number of bytes. You say, give me 1,000 bytes, or give me up to 1,000 bytes. It'll give you between 1 and 1,000 bytes back. So you have to, it just depends on how fast the network is and when bytes are arriving. So you have to keep repolling, and that's all hidden from you in the string socket. You just say, give me a string, and when it finally accumulates an entire line, it gives it back to you. So you learned how to access SQL from C#. This is just sort of describing this. So LINQ, several people asked could they use LINQ, and we said yes, but it provides methods that let you access data structures, also databases, as if they are databases. So it lets you do things like run select statements on lists or sets. So you can make even your in-memory data look like your in-memory data structures look like a database. Okay, we looked at a variety of software architectures. So object-oriented architecture is what we use the most. That's what you're most familiar with. We organize programs around classes and we use classes for information hiding. We exploit polymorphism and inheritance and interfaces. There was a question posted, I never answered it, and someone must have, or it got deleted, about PS12. And the question was, do we have to use, so in the example I gave you using sockets, there was a client connection class that kept track, there was one client connection object per request. And the question was, do we have to use something similar to that in PS12? And I was trying to think of a good response. What do you think was going through my head when someone said, do we have to use, basically, do we have to create a new class in this program? Yeah.
You have to, but I don't know why you wouldn't.
Okay. He said, he's answering the question, saying you don't have to, but you probably want to. I mean, my thought was more on the line, it's important to grow past the point where you think of writing a class as a burden. Okay? So I know you take courses like 1410 and 2420, and the focus of your week might be implementing a class, and so you start thinking about classes as being these things that you wish people would give to you that you don't have to deal with. But no one ever asks, do I have to use a loop? There was a time when you struggled with loops, but people don't say to me, do I have to use a loop in this assignment? But they do still ask, do I have to use a class? Okay? You don't use a class if it's a bad thing, if it doesn't matter. But for this assignment, creating a class to encapsulate each request was actually pretty convenient. So didn't have to, but so anyway, enough said about that. We looked at the client-server architecture. So you did a lot of that with PS10 and PS11 and PS9, using a remote server and client-server communication over the network. I'm curious, how many of you actually did the lab and managed to push your server up into Azure? Anybody do that? Didn't have time. I mean, I'm not surprised because you're very busy. But if you're ever curious about it, the lab will still be there. And it's not that hard if you have a working PS11 or a working PS10, for that matter. PS10 is even easier to push to Azure. You just sort of create an account and then do one click in Visual Studio. Getting the database up is a little more involved. Check it out and see. You can have your code running on the cloud. We looked at the pipe and filter architecture. So that was the very first assignment. We were working with command line parameters and reading from standard in and writing to standard out. And I think I mentioned at the time that the reason I do this for PS1 is because I keep running into students in other classes that have 3,500 as a prerequisite. And you ask them to write a program to, a command line program that reads from standard in and writes to standard out. And it's like, they think that's the weirdest thing ever, and maybe it does seem weird to you. To me, it's just that was the only architecture there was when I came up. I see this in 4150 where I have students do the algorithm of the week on Caddis, and they have to read from standard in and write to standard out. So it's good to know how to do that. Event-driven architecture, we built our GUIs that way. And speaking of GUIs, we did that. We relied heavily on events and callbacks and GUI components and so on. We talked about the model view controller architecture. We used an architecture, kind of a typical kind of architecture where you have a database backend to keep track of your data. And we talked about RESTful architectures, where there's clients that provide services via sort of in a REST style, where all the state, there's no state in the clients, the state's all in the server. Okay? Any questions about any of these architectures? Yeah.
Is it mostly going to be JSON, or is it going to be like XML, or is it going to be Scratch?
When you say it, you mean the final?
Just anything, because we only really work with JSON for the most part with all the...
Yeah. So, actually, when you did PS10 and PS11, your services will support XML format. So, if the incoming request says, I want the response in XML, your implementations will produce XML automatically. Because it was, already you didn't have to, in PS10 and PS11, you did nothing to serialize the outgoing, you didn't have to deserialize the incoming objects or deserialize the outgoing objects. It's done automatically. And that's just based on the preference the client expresses of what they're sending and what they want to see. So you wouldn't have to change anything for it to do XML. Now, what would it take in PS12? What if in PS12 I had said you must look at the incoming headers and decide whether you're receiving XML or you're supposed to send XML? How would that have complicated things? Would it have been a big deal or a small thing? Yeah, you just have to check the header and before you did any deserializing, and you just have to know what's the method called to deserialize to and from XML. So it would have been a relatively minor change once you got everything working. Any other questions? Used a whole raft of software development tools. I'd like to hear what tools did you use this semester that you really liked learning about, if any? Yeah.
GUI. Just create the GUI within that forums.
Okay. So the GUI tools. Any others? Yeah.
The profiling tools in Visual Studio, because I've never seen that in the Linux system before.
Okay. So profiling tools. Again in 4150, I'd have students saying that the program they were submitting was too inefficient. It's failing tests because of that. And so I'd just tell them, profile it, see where it's spending its time. Yeah.
I enjoyed the databases.
Okay. So these are all, especially databases, that's a huge topic. And actually, concurrent programming is a huge topic. So just about anything you mention in the class is a huge topic that you can learn more about, often with courses that we teach. So if you like databases, take the database course. Yeah.
Git initially drove me kind of nuts, but after I learned how to use it, I was really grateful that I could push my program up and work on it on a different computer later. So it was really convenient.
Yeah, Git is a mixed blessing. It's fine if you understand, if you have a good mental model of how it works, it's, you can use it pretty seamlessly. If you don't quite understand what's supposed to be happening, it's also easy to screw things up. And we saw quite a bit of things screwed up in all kinds of ways in Git. The TA saw it a lot. So, yeah, it's good to learn Git, but it can be a little bit rough when you're first learning it, especially with merging. That's where the problems first start to occur. Okay? Any other favorite tools? Okay, we talked about software engineering. So a lot of what we did was what I would call personal software engineering, sort of habits that we try to build into you about how to develop software by yourself or with one other person. The thing to remember is it's been recognized since the 40s that it's hard to produce software. And the hardware gets more and more powerful, the demands, the kinds of things we want to build becomes more and more ambitious. And the software tools get better, but not fast enough. So we just always seem to be not quite have a handle on the software development business. It's a hard thing. Version control we just talked about. We talked a lot about software testing. So what did you learn about testing this semester? Yeah?
If the class goes really bad, you're going to have an assignment that's on testing.
Okay. Okay. I mean, when you slacked off on testing, what happened? You probably didn't do so well on the grading tests. So yeah, testing is a pain, but it's just a different kind of programming, and it's you really can't ignore it. So anyway, we've got some terms that you be sure you understand the difference between black box testing and white box testing. Any of you try programming with continuous testing? How'd that work out?
Slows your machine down so much.
Slows your machine down?
It's kind of nice to have that continual feedback, because when you're changing things and you see how it impacts the testing, it lets you know that what you did was either correct and you need to continue to adjust it.
Okay. Did the speed bother you?
Not so much, no.
Yeah.
Hurt battery life a lot.
Hurts the battery life? Yeah, I can imagine. Yeah. You probably got the fan. You have a fan in your computer? It's like on constantly. Okay. We talked about debugging. It says experienced debuggers are roughly 20 times at finding defects. I don't remember where that stat came from. Do you believe that? Do you think can you see being 20 times better than you used to be? And what's the difference? What makes you a better debugger? Yeah.
I think it's just from experience, and like when you start getting more experiences under your belt, you're like, oh, I've seen that before.
Yeah.
I know what I need to do.
Yeah, that's how it is a lot of times for me in my office when people come in. I've quite often seen it before. What else makes you a better debugger?
It's like I know if I know what the problem is, it's like I don't know where in the code I might be wrong, but I know what to look for to fix it.
Okay. Yeah.
You see how common null pointer exceptions are?
Okay. Yep.
Putting breakpoints in certain spots and fewer of them.
Okay. So it's a combination of sort of mindset, experience, tools. And then you go program in C or C++, and it gets harder because you don't get these nice exceptions that tell you what line the problem occurred on. So got that to look forward to if you've never done it. You got lots of experience with programming to a specification, because I would typically give you pretty detailed specifications, and you program to them. We tried to hold your feet to the fire at writing good comments. Hard to grade though, so we don't do a perfect job. I don't know why I threw XML and regular expressions on this slide, but that's stuff we learned about. So there it is. We talked about database design. So designing tables. And again, I did the design for you. When I first used the Boggle assignment, I would not do that. I would have the students design their own tables, and it did not work well at all. So I changed my mind. But you take a database class, you'll get experience with designing your own schemas, with keys and constraints. This is also easy to ask questions about. So be sure you understand about foreign key constraints and primary keys and how to do simple queries and simple modifications. There's always more to learn about SQL, so you could write ever more complicated queries that do ever more involved things. But as you saw in PS11, you can get by on the basics. So I've spent parts of a couple of lectures talking about runtime structures. What memory does your computer use at runtime? How does your computer use memory at runtime? How does it, when a program is running, you got to understand there's a stack, there are stack frames on the stack, there's a heap, there are references that go from the stack into the heap. In C#, or Java, you never have references back into the stack from the heap. That happens in C and C++. So when you learn those languages, the model has to change somewhat. There's, call by value, call by reference. We talked about the virtual method table one of those times. So have some familiarity with the runtime structures that make programs work. We talked last week about intellectual property, and if you looked at the sample exam, you saw there was a few questions about that. So understand the difference between copyright, patent, trademark, and trade secrets. And we just talked about ethics, so I won't review that. Those are just the main points that we talked about. So that's the slides. Any questions you haven't wanted to ask and now want to ask? While I'm standing here, yeah?
Will we have to draw stacks on the exam?
Well, you have to draw stacks on the exams. Probably not, because I hate to grade those things. That's I've done that as well. So what I imagine I would do is ask questions of the form, if you were to draw this picture, how many stack frames would there be, or something like that. I might ask questions about the diagram that you're not graded on the diagram, but you're graded on understanding what it would look like. Yeah?
What about model view controller diagrams?
Okay, he's saying model view controller diagrams, you mean UML, I think. Yeah, you need to know what UML is, but I'm not going to ask you to draw UML diagrams. Yeah?
With stacks on the, I guess, quiz of last year, the final for last year, one of the stack frame, or like, not frame, but one of the slots on one of the stacks is this.
Right.
When does that get passed? I just don't
Okay.
remember.
So when is this? So remember, this is often called the implicit parameter. So anytime you're invoking a non-static method or calling a constructor, this is a parameter. And so if you're doing, O.f, then the value of O will be passed as the this parameter to f. Other questions? Yeah?
I just wanted clarity on the difference between synchronous and asynchronous. Because it seems like they've been used like synonymously, or that's how
No, they're not. They're opposites.
Okay.
So think about sockets. So regular raw sockets, you can use them both synchronously and asynchronously. So asynchronous mode on a raw socket, if you want some bytes, you just call a method called receive. Socket.receive, and then you wait for it to return some bytes to you. And so that's synchronous because we asked and we have to wait. We're blocked while the socket waits for bytes to come in, and then it delivers them to us. And so basically the socket is working in the same thread as we are. Asynchronous is more like begin receive. So we have one thread that we're operating on. We say, please get some bytes, and sometime in the future when you get them, call this callback on a different thread, and then I'll deal with that. So that's asynchronous. We're sort of on two different timelines for us in the socket code. Other questions? Yeah.
Can we go over extension methods real quick?
Okay. So what do you want to know about them? How to do them?
Yeah, just like the syntax, like what it actually means.
Okay. So to do an extension method, let me get a pen here. Wow. So how do you make an extension method? Let's say you want to make an extension method f that returns an integer. How can you recognize that what you're dealing with is an extension method? Yep.
This keyword.
Okay. So you would put this before the first parameter. And I can't remember the exact order it comes in, so help me out. Does this come first?
I think it's this.
So we say something like this int in Boolean b, and then you have some code, and somewhere down there you return an int. So that is an extension method. I think it has to be static, doesn't it?
Yes.
But what's the effect of an extension method? What does that keyword accomplish for you? Yeah.
You can then call in.f.
Okay. So it makes it look as if f is a method in the int class. So you could now do something like this. You could say 3.f of true. So the first parameter is taken from before the dot. That's where the n comes from. The rest of the parameters are taken from there. And it's not really, this method f doesn't have any special access in the int32 class. It's just using public methods, public operators, whatever. But sometimes it can be nice to have a uniform way of invoking things. Sometimes I overlook this, but why is it useful to be able, see, when I learned to program, we didn't have this object.f notation. We just always called a method and gave all the parameters here. You never saw x.f. What's one big thing you take advantage all the time, that before you call a method f, you give the object that it applies to? Just nuts and bolts in Visual Studio, yeah.
Just readability, or like immediately looking at it, you know exactly what you're operating on.
Okay, so it emphasizes the object you're operating on, but I'm thinking sort of a more pragmatic. Yeah.
I mean, when you do x dot whatever, typically in Visual Studio you get that dot and goes, here's all the stuff
That's
you can
right.
do with this.
So the IntelliSense aspect.
Yeah.
So you do x dot and you can see what all the options are. Whereas if you just have to type the f, and then I guess if languages were different, the IntelliSense would work differently, but we all depend on that. Any other questions? Okay, so I just want to remind you, first of all, that the exam is 2 days from now, from 1 to 3, so don't come at 2. Come at 1. And it will be, nowadays when I make up exams, I make them 25 questions, 4 points apiece. So over time I've gotten away from bigger questions that take up more points. I do that for the midterm because time is shorter. So I like lots of smaller questions. And the other thing is, one of the goals of this class is to sort of get everybody up to speed at creating reasonably complicated programs, so that when you go out and take your other classes, you have a certain baseline of abilities. And so you've all soldiered through to the end. I know it's been a long, hard semester, and you've spent an obscene number of hours doing your assignments. And you probably resented it at times, and you might resent it right now. But hopefully this experience benefits you going forward, where you can succeed in the rest of the program and graduate and make more money than I do. So I hope that happens. So, take care.
Yeah, I'm ready to go.
lot of questions that are hard to ask without